Hi, ma'am. Hello, ma'am. Can you listen?
Yes. Anu, am I audible?
It's not audible here. Just one second. Just 1 second, actually. Hello? Yes.
Yes. Anu, am I audible?
Yes, now it's audible. Yes. You can start. Thank you so much. You joined to us. Students are listening to you, and if they have
Anu,
any
your
questions,
voice is.
you can listen to me. It's not audible. So,
Hello, everyone. Hopefully, I am audible to you, but I couldn't listen to you people. As Anu ma'am requested me to start the session through WhatsApp message. So let me begin with the session. First of all, I am very much thankful and grateful to Anu madam and her institute for giving me opportunity to interact with the students. And hopefully the students are UG students. I am given the duty to share my views with the PPT. Hope the screen is visible to you. Whether the presentation is visible to you. Yes, I received the message from Anu ma'am that it is visible. Now, actually, I couldn't, I think students or audience are not visible to me. Uh, it would be better if I could see the audience first of all, so that I can interact with them, because I want this session to be more interactive than just the delivery of lecture. I want that session should be interactive, but somehow due to I think some audio problem or some technical problem, I am not able to hear you or listen to you. So I'm starting with my lecture. And if there is any doubt in between, you can always raise the question either through Anu madam, through WhatsApp message, or through any message on the Teams Microsoft, right? Now, first of all, what is hypothesis testing? As Anumam told me that students are not very much from the statistics background, but they know somewhat about the statistics. Now, that means the concept is new to you, that what is hypothesis testing? Firstly, hypothesis testing means testing any claim regarding population. I assume that you know the meaning of population and sample. Population, that is basically all the items concerned to given inquiry, and sample is a small part from that very population. Like if I have to study the average marks of your class, then population is your whole class. Will be core students of your institute. But if I take the sample that uh, let it be, I have shortage of time, I have shortage of finance, I couldn't study all the units, then what will I do? I will take the sample from it and study the nature of population on the basis of that very sample. That means I will take sample from that very population, that is few units. I will select the few units. There are so many sampling techniques through which I can select the sample. And on the basis of that sample, I will draw my conclusions about the population. And drawing of that conclusions about the population, or testing the claim about the population, that is called as hypothesis testing. That means I have hypothesis means setting the claim about the population, and to test whether that claim is correct or not. That means I have to test whether the claim about which I set about the population, that is correct or not. How I can check that whether the claim is correct or not? That can be checked through the sample taken from that very population. If I check that claim through the sample drawn from that very population, and I draw the inferences whether the claim set by me, that is accurate or not. This whole process of testing the claim, it is called as hypothesis testing. I hope this much is clear to you, that what is hypothesis testing, right? That means there is a problem that I have to test a claim, right, on the basis of sample drawn from that very population. Let it be, when I discussed
Hello.
about your class with Anu ma'am, she told
Hello.
that her class is above average. If class is above average, that is claim about your class, that is claim of Anu ma'am about your class, that class is above average, right? If class is above average, that means it is a claim. Now, there are two ways to check that claim. One is that I take the marks of all the students of your class and find out the average. If average is more than 80 or more than 60 above average, that means let it be more than 50, right? If it is more than 50, that means that claim is correct. But if it is not more than
Hello.
50, that means that claim is not correct. right? That is through the population. But sometimes it is difficult to take all the units of population, either due to shortage of resources, that is there's shortage of finance, shortage of time, anything can be there. Then what we do, we take a sample from that very population and we draw the average of that sample. When we calculate the average of that sample, now claim is that students are above average, and let it be my average is average of sample, that is 49. Now should I accept the claim or not? Because 49 is near to 51. Should I reject my claim or should I accept my claim? This whole process, that is called as hypothesis testing. Hope this much is clear to you. And now I move to next slide, that when and why we use the hypothesis testing. Basically statistics, there are of two types: descriptive statistics and another one is inferential statistics. Descriptive, when we describe about the nature of the series or nature of population or nature of sample. When we describe about nature of sample or population, that is called as descriptive. In this we use mean, standard deviation, variance, correlation, this kind of techniques we use. There no inferences are drawn, that we have no claim, we are not taking any claim, we are not testing that. But when we draw inferences from small unit about the whole population, that statistics is called as inferential statistics. And here we use the hypothesis testing. And basically hypothesis testing is used to compare the parameter with statistics. Now what is parameter and statistic? Parameter, it is constants of the population, these are called as parameter. And constants of sample, these are called as statistics. When we compare the statistics with parameter, then this is called as this is one of the way of hypothesis testing. And we, if we compare two parameters, that is two, we compare two populations, whether they are equal, whether there is any significant difference between two parameters, that is also one type of hypothesis testing. Hope this much is clear to you. Hope this much is clear to you. Then next is process of hypothesis testing. What steps we take during the hypothesis testing? First step is formulation of hypothesis. First of all, we set the claim, right? That is formulation of hypothesis. I will explain it in further slides. Then we decide the level of significance. But then we select the tail, whether we have to test only one side or on the both sides. If it is one side, that whether it is right side or the left side, then we select which test I have to apply for the hypothesis testing. Then I have to select, decide about the acceptance and rejection of null hypothesis. Then we have to draw the conclusion or inferences. These are the steps of the hypothesis testing, process of hypothesis testing. Now the first step is formulation of hypothesis. In formulation of hypothesis, what we draw, so first of all we set the hypothesis, and there are basically two hypotheses. There is set of hypotheses and there are two hypotheses. One is null hypothesis and another one is alternative hypothesis. Null hypothesis and alternative hypothesis. Null hypothesis, that means it is claimed regarding the population which is considered to be true until and unless it is proved to be false, right? Suppose that, as Anu ma'am told me, that average marks of her class is more than 50. It is claimed that it is claim set by Anu ma'am that average marks are more than 70. I will take null hypothesis as mu is equal to 50, because null hypothesis is always in the form of equality statement. It cannot be in greater than, less than, or not equal to. It will always be in the form of equality statement. I will set the claim equal to 50. Let it be, it is claimed that average marks of your class are more than 70, then the null hypothesis will be equal to mu is equal to 70, and it will be considered true until and unless through the sample, through the statistic, I prove it to be wrong. That is, I will perform the complete test, and if I prove it wrong, only then I will reject the null hypothesis. Otherwise, it will be considered true. And alternate hypothesis, on the contrary, it is considered to be false, and it is rejected until and unless it is proved true and accepted. That means initially null hypothesis is true, and through the procedure of hypothesis testing, we draw the conclusion that whether we have to accept the null hypothesis or reject it, whether we have to accept the alternate hypothesis or reject it. And null hypothesis, that is always in the form of equality, and alternate, that is always in the form of inequality. It can be not equal to 70. It is case of two-tail test. It is greater than 70, and it is less than 70. This much is clear to you. If it is not clear, then you can ask questions till now. Or should I continue further? One thing more, always the symbols or these values used in the hypothesis testing, these belong to population. That is, these are parameters, not the statistic. If I take whole population and calculate mean of that, that will be represented in hypothesis. Sample mean or sample variance or sample proportions, they are not represented in hypothesis. Any doubt till now? Any doubt? Should I continue further? This is example of formulation of hypothesis. Suppose the claim is that the mean sales are equal to 50. Then hypothesis will be null hypothesis mu is equal to 50, and alternate will be mu is not equal to 50. Right? If there is any doubt, you can jot it down. You can note that, and we can discuss it at the end of the session also, right? Is it okay, Anu? We will discuss all the doubts at the end of the session. Is that okay? Then second step is decision regarding level of significance. Actually, I have not received any response, and I am assuming that we will interact at the end of the session. Then second step is decision regarding level of significance. Now, what is level of significance? This is very important concept in the process of hypothesis testing. Basically, there are two types of error in the process of hypothesis testing. First is type 1 error, and another one is type 2 error. Type 1 error is when null hypothesis is rejected, but it is actually true. That is, if the claim regarding the population is true and I rejected it, then this is called as type 1 error. And type 2 error is null hypothesis is not rejected, but it is false. That means it should be rejected, but I accepted it. Then it is type 2 error. Probability of type 1 error, that is called as level of significance, and it is denoted by alpha. And probability of type 2 error, it is denoted by beta. I explained it with you. I explained it with this simple example. Here, when I talk about null hypothesis and alternate hypothesis, in most of the democratic countries, we assume that, we take it like that, a person is considered to be innocent until and unless it is proved to be guilty. That means null hypothesis, person is innocent, and alternate hypothesis, person is guilty. That means until and unless whole process is done of the, that is, you have to present all the evidences in front of judge, and you have to do all the legal actions. Until and unless you prove that person to be guilty, it will be considered that person is innocent. That means null hypothesis is true until and unless it is proved to be false. Like, person is innocent until and unless he is proved to be guilty. Similarly, alternate hypothesis is that person is guilty. It will be accepted only if through evidences it is proved that person is guilty, right? And now I explained the concept of type 1 error and type 2 error with the same example. That means person is innocent, but I proved it to be guilty. In the legal procedure, person is proved guilty, but actually he was innocent. It is error. It is type 1 error. Here, person is guilty, but court released that person. Court proved that that person is innocent. It is also an error. It is type 2 error. Here, I represented it in the form of table that when null hypothesis is true and I accepted that, it is a correct decision. When it is false and I rejected it, again it is a correct decision. But when it is true and I rejected it, it is an error and it is type 1 error. And when it is false and I accepted it, again it is an error and it is type 2 error. So both the errors, they are now which one is more dangerous? Which error I should control? Whether type 1 or type 2? Can any one of you explain that? Which is more dangerous, type 1 or type 2? Type 1 is person is innocent, but he is proved to be guilty and punished, right? And type 2 error is person is guilty, but he is released as he is proved innocent, right? Which is more dangerous according to you? Can you tell me through the message? Which is more dangerous, whether type 1 or type 2? See, both the errors can't be controlled simultaneously. We at one time we can control only one error. Both the errors can't be controlled simultaneously because it is difficult to control both the errors if we make the laws such that if we make strict laws, then it is quite possible that guilty persons will be that innocent persons will be punished if laws are strict. But if laws are liberal, then it is possible that guilty
Is
persons will
it
be
audible?
released. Yeah, now you are audible.
Now, okay, so students want to give you the answers.
Okay. Which one is more dangerous, type 1 or type 2?
Type 1 or type 2?
Type 1.
Type 1. Why so? Why so?
Ma'am, he is not guilty,
Exactly.
so he is not getting the punishment.
Yes, she or he should not be punished, but we punished him, right? That means a person who murdered somebody and I release that, that means that is not more dangerous as compared to a person who hasn't done any crime, but I punished him. Definitely it is true. Right? Because if we will punish any innocent person, that will be more serious as compared to if we release a person who had done any crime. So we will always try to control type 1 error first. Definitely type 1 error is more dangerous. Very true and very good, right? So we try to control type 1 error as compared to type 2 error. If that means, as I already told, that probability of type 1 error, that is level of significance. That means we try to keep the level of significance at very low levels. It can be 5%, 2%, or 1%, depending upon the nature of the study. If it is, let it be studies regarding the medicines, then we have no scope of any error. Then we will keep that level of significance 0. But if studies for the social sciences, like it is marketing study, it is study of human behavior, it is fluctuating. So we take here 5% level of significance. That is, there are 5% chances that your null hypothesis is true, but we reject that. Because here human behavior is involved, which is very much fluctuating. That's why here we take 5% level of significance. That means we try to control the type 1 error as compared to type 2 error. Definitely it is true, right? Now I move towards the next step, that is decision regarding the selection of tail. There are basically two types of tail, two tail test and one tail test. What is two tail test? when both the tails are involved. That is, you have to test the hypothesis with both sides. You have to test whether the your hypothesis that is rejected on the left side or on the right side. That means you have to test on the both side. That means rejection region is on the both sides. And in one tail test, only one side is involved and region is only on the one side. It can be of two types, right tail as well as left tail. I think it will be more clear from this diagram. This is, can you tell me that this is of which distribution? Diagram is of which distribution? Do you know this? What type of curve is this? And in to which distribution this diagram belong to? Have you ever seen this diagram? Okay, I
Ma'am,
take it.
confidence interval.
Yeah, confidence intervals are these, but this diagram that belong to normal distribution. It is diagram of normal distribution. It is a bell-shaped curve, or it is, you can say that this diagram is of standard normal variate. It is distribution of standard normal variate. And since here you can it is very much evident from this diagram that both the tails are involved. That I have taken the rejection region, that is shaded area, on the left side also and right side also, right? Then this is called as two-tail test. If I take the rejection region on one side, then this is one-tail test. Let it be I have taken the rejection region on one side only. Then this is left-tail test. Here rejection region is taken on the left side. And here rejection region is taken on the right side. Clear? Clear? I think it will be more clear from these examples. Let it be hypothesis that mean sales are equal to 50. Here null hypothesis, as I already told you, that it will be always in the form of equality. Mu is equal to 50, and alternate will be equal to mu is not equal to 50 in the form of inequality. And since it is not equal, that means it can be less than 50 or it can be and in case of right tail, let the hypothesis like that mean sales exceed 50. Here mu is equal to 50. Here mu is greater than 50. Right? If it is equal to 50 or greater than 50, only one tail is involved here. That is right side is involved. Right? Then left tail test. Here mu is equal to 50 and sales are less than 50. That means mu is less than 50. Here only left side is involved. The mu is less than 50. Therefore, it is left tail test. I hope this much is clear to you. Should I move forward? Should I continue with the fourth step? Then next is selection of appropriate test. Now, I have to select the test for applying the hypothesis testing. And there are so many test statistics which can be applied. Basically, what this test statistics measure, it measures the difference between statistics and parameter. I already told you that statistic is sample constant and parameter is population constant. And whether the difference between statistic and parameter that is significant or not, depending upon the variations in distribution, that is measured by the test statistic. That means, as I already told you, that if I took the sample of your class and average of marks comes out to be 49 and claim is that average marks are more than 50, that means parameter is 50 and statistics is 49. Whether the difference 49 minus 50, it should be taken as significant or not on the considering the variations in the distribution that is calculated through test statistics. And it test statistics, they can follow normal distribution, t distribution, f distribution, chi-square distribution, and many more, depending upon the nature of population, nature of the data, nature of the series you have. Basically, while selecting the test, we see whether our population is parametric or non-parametric. Since in your curriculum there is only t test and test related to proportions and mean, which can be performed through z test, and both of these tests are parametric tests. So I have taken here only parametric selection of parametric test, right? Otherwise, what is difference between parametric and non-parametric test? Parametric test is where nature of population is known, and non-parametric test where nature of population is not known, right? If I know the parameters of population, that I know the mean, I know the variance, then it is parametric test. But if I don't know the parameters of population, then it is called as non-parametric test. Basically, in parametric test, population, we have data, metric data. That is, metric means measurable data. Either it is on ratio scale or it is on interval scale. But in non-parametric test, data is not metric. It is non-metric. It is either on the interval. It is either on the that is nominal scale or ordinal scale, right? If now population is parametric, then we consider whether it is a small sample or large sample. A large sample means size of sample is greater than 30. Then we apply Z test, because we assume that large sample, their sample distribution converges into population, right? So sample statistics can be taken as representative of population parameter. So here we apply Z test. But in case of small sample, we apply T test or F test. Z test can be applied for comparing the proportions, means, variance. T test can be applied for comparing the means up to 2 samples. That is, if there are two uh, independent, one independent variable with two categories, then we can apply T test. And F test, that can be used, it is again a small sample test. It can be used to compare the variance, or it can be used to compare the mean for more than 2 samples. This technique is called as ANOVA, that is analysis of variance. Then step 5, we have to decide whether null hypothesis is accepted or rejected. It can be decided on the basis of critical value. Critical means, as one of the students now told me, that confidence interval, the diagram show the confidence interval. Definitely, the diagram shows the confidence intervals. That is, this value 1.65, it shows the confidence interval. That means area left to 1.65, it is acceptance region, and area right to 1.65, that is shaded area, it is rejection region. If I take two tail, then both the tails are involved, and it is, let me explain here. Here it is confidence intervals, right? This value is of confidence intervals, right? Now, in case of two-tailed test, if the calculated value of test statistics that lies beyond its critical values, right? If lies it beyond its critical values, just a moment. Here it is 0.475, value should be 0.475, and it is 0.025. Similarly, here it is 0.475, and it is 0.025, because it is two-tailed test, and I have to divide the probability in two parts. That's why, right? Here, two-tailed test, if calculated value of test statistics that lies beyond its critical values, then null hypothesis may be rejected. These are the critical values, minus 1.96 and 1.96. If your calculated value of z, it comes out to be 2.08. So it lies beyond these limits, minus 1.96 and 1.96. Acceptance region is this non-shaded area. It falls in the rejection region, so null hypothesis may be rejected. It is case of two-tailed test, and level of significance is 5%. That means 5% that is divided into two parts, 0.025 and 0.025. Here it is 0.475 and 0.475, because it is normal distribution curve, and total area under the normal distribution is 1. and it is perfectly symmetrical. Half area is 0.5 and this half area is also 0.5. And if it is 0.025, this much area is 0.5, then subtracting this 0.025 from that very 0.5, it is 0.475. And if I see through the, if I take the value from the standard normal curve of Z distribution, then I will find out that for probability of 0.475, value of Z comes out to be 1.96, this much. And since it is symmetrical, on the left side value is also 1.96, but it will be in negative sign. So these are the critical values, and if calculated value of Z that lies beyond these limits, null hypothesis may be rejected, otherwise it will be accepted. This will be decision regarding acceptance or rejection. Similarly, if it is 2%, case of 2%, then probability of shaded area, that will be 0.01 on each side. And here for the 0.49, tabulated value will be 2.33, and this will be acceptance region between minus 2.33 and plus 2.33. Let it be calculated value comes out to be 2.09, then it will be accepted. Null hypothesis will be accepted. And if value comes out to be 3.8, then it will be in rejection region and null hypothesis may be rejected. Right? I hope this much is clear to you. Then this is case of two-tailed test, and here level of significance is 1%, and on one side probability will be 0.005. Since it is two-tailed, so level of significance that will be divided into two parts, and here for 0.495 value will be 2.57. So critical values will be plus 2.57 and minus 2.57. Again, if calculated value will be in between this area, then null hypothesis may be accepted. If it falls under the shaded area, then null hypothesis may be rejected. Right? This is case of two tail. Now coming to the case of right tail. If calculated value of test statistics, it is more than its critical value, then null hypothesis may be rejected. Otherwise, it is accepted. This is case of right tail. In case of right tail, this is case of right tail. It is 5%. Since only right tail is involved, I took the probability of 0.05 on the right side, that is this shaded area. Half area is 0.5, so 0.45 is here. And from table, I take the value of this Z statistic, it is 1.65. So critical value is 1.65. If the value is more than, calculated value is more than 1.65, let the calculated value is 3. Since it is more than 1.65, null hypothesis may be rejected. Let it be calculated value is minus 3. Since it is less than 1.65, so null hypothesis may be accepted. That means in case of right tail, any negative value of Z calculated, that will be accepted, because rejection region is only on the right side. So negative values will be accepted here. It is case of 5% level of significance. This is case of 2% level of significance. The critical Z value is 2.06. And this is case of 1% level of significance. The critical value is 2.33, right? And now the case of left tail. If calculated value of test statistics that is less than its critical value, the null hypothesis may be rejected, otherwise accepted. This is case of left tail. Here 5% level of significance. Again 0.05, I have took this probability as the probability of shaded area, that is rejection region, and it is on the left side because it is left tail test. And this whole area which is non-shaded, that is this 0.45 probability area and 0.5, this is acceptance region, right? And minus 1.65 is the critical value of Z. If any value more than this minus 1.6, that will be that leads to acceptance of null hypothesis, and any value which is less than minus 1.65, that leads to rejection of null hypothesis. Now what is this any value? This is calculated value of Z, right? And this is case of 2% level of significance. Here probability of rejection region is 0.02 and critical value is minus 2.06, and for 1% it is minus 2.33. 0.33, and all these values I have represented in this table, which I have explained to you, right? On the basis of this, I accept or reject null hypothesis, or accept or reject alternate hypothesis. This is on the basis of critical values. And another way, alternate way, is p-value or probability value. Now, how we calculate p-value or probability values? Sometimes SIG value is mentioned. That is also p-value or probability value. In this, we calculate Z statistic first. Then we calculate area right to calculated value of Z statistics. This is example that I have taken. I have taken here two examples. Let it be calculated value of Z is 1.5. I will take this area from the standard normal area curve. 0 to 1.5, it is 0.4332, and area right to 1.5, this will be, because I explained that half area is 0.5, and right to 1.5, it will be 0.5 minus 0.4332, it is 0.0668, and p value is 0.0668 here. If calculated value of Z is 2, then area between 0 and 2 is 0.4772, and area right to 2 is 0.5 minus 0.4772, that is 0.0228. So here p value is 0.0228. How we will decide about the acceptance or rejection of null hypothesis? Depending upon the p value. If p value is less than level of significance, then null hypothesis may be rejected. Now you have let it be, you have decided the level of significance as 0.05. So 0.0668, it is more than 0.05. So null hypothesis may not be rejected. But here, since the value is in second case, it is 0.0228, it is less than 0.05, therefore null hypothesis may be rejected, right? But if in case I take alpha is equal to 0.02, then both the values, in both the cases, null hypothesis may be accepted, because both the values are more than 0.02. And if I take alpha is equal to 0.10, that is 10% level of significance, then in both cases null hypothesis may be rejected. I hope this much is clear to you. Any doubt till now? Any doubt till now? Should I continue further? Clear? Okay. Then this is step 6, conclusion or interpretation. If I accepted null hypothesis or rejected null hypothesis, that is not enough in hypothesis testing. I have to interpret what I have concluded from that. Like if my test hypothesis was that mean sales are equal to 50, then if p value is 0.0668, that means here null hypothesis may be accepted. That means this hypothesis will be accepted. My interpretations will be mean sales are equal to 50. And in second case, p value is 0.0228. Here my null hypothesis may be rejected, so alternate will be accepted, and here alternate was mean sales are not equal to 50. That will be my decision, that will be my interpretation or conclusion. This is all about various steps of hypothesis testing. I hope this much is clear to you. If there is any doubt till now, you can let me know. Any doubt? Any doubt till now? Okay. Then next is Z test. Z test is for large sample test. I have told you that we have to calculate test statistics, and test statistics that can be calculated according to many distributions. But in your syllabus, your curriculum, there are two distributions. One is Z test and then another one is T test. Here, in case of Z test, you have to perform these two applications, that is difference between sample mean and population mean, and difference between two population means. And these two applications, last two, difference between sample proportion and population proportion, and you have to test the difference between two population proportions. Now coming to first test of hypothesis about the population mean. Here formula of Z will be mean minus mu over standard error of mean. Now let it be mean height of a random sample of 100 students is 64 and standard deviation is 3, right? Test the statement that mean height of the population is 67 at 5% level of significance. Now what are you finding out from this statement? Mean height of random sample of 100 students, that means n is 100. Mean is 64 and here standard deviation is 3. You have to test this statement that mean height of population is 67. Now mu is equal to 67 because I told you that population mean that will be taken in hypothesis. So null hypothesis is equal to mu is equal to 67. And since here single equal to 67. Now I will put all the values in the formula mean minus mu divided by standard error. Standard error minus 10. Now, what are the critical values of Z at 5% level of significance? I have explained you in this table. 5% plus minus 1.96 for two tail, right? And if I take these two values plus minus 1.96, then what can I interpret for plus minus 1.96? Value of Z, it is minus 10. That means it lies beyond the limits of critical values. So null hypothesis may be rejected. And what will be conclusion? That population mean is not equal to 67. Now, by taking the another side, that is difference between two population means, here formula will be Z is equal to mean 1 minus mean 2 over standard error mean 1 minus mean 2. And by taking this example, that two different samples from two districts, these are the yields of two districts, mean 1 648, mean 2 495. These are values of sample size, that is 190. These are the values of unbiased estimate of population variance. You have to test the claim that mu1 minus mu2 is greater than 150. And I have to apply all the values in the formula. Here, first of all, I will calculate standard error. I have been given S1 square N1. I will put all the values in this formula. This standard error will be calculated. And if after calculating this standard error, I will calculate Z by applying all the values in this formula. Z comes out to be 1.809, right? Now it is a right tail test because hypothesis was mu1 minus mu2, it is greater than 150. And for right tail test, critical value of Z at 5% is 1.645. So calculated value is 1.809. Critical value is, it is minus greater than, right? It is 1.645. Since calculated value is more than critical value, therefore null hypothesis may be rejected. That means we will conclude that difference of two means will be greater than 150, right? I think this is clear till now. It is applications. I have explained the application of Z test in case of means, that is in case of one sample mean and in case of two population means. I hope this much is clear. Should I move to proportions? Any doubt till now? Any doubt? Okay. Okay. I will continue with another test. It is test related to sample proportions and population proportions. Now Z is equal to P minus capital P. Here small p, it is symbol used for the statistic, that is sample constant, that is sample proportions. And capital P is symbol used for population proportions. And this is standard error. What is standard error? Standard error is basically standard deviation of this population proportions. these values of proportions, if I take the variations between these proportions, this is called as standard error. Let it be I have taken sample of 10 students many times, and population proportions comes out to be different each time, and I find out variations between that proportions, that is called as standard error of proportions. Now this is the example of difference between sample proportion and population proportion. Let it be 324 throws of 6-face dice, odd number appeared 180 times. Can it be concluded that die is fair? If dice is fair or not, it can be concluded through hypothesis testing. First of all, I will formulate two hypotheses, null hypothesis and alternate. Null hypothesis is p is equal to 0.5 and alternate p is not equal to 0.5. Now, sample proportions are favorable cases over total cases. One, it is favorable case, whatever is the success rate in your sample, and it is total case, 324. It comes out to be 0.555. And capital P is 0.5. Q can be calculated as 1 minus P, right? We all know that probability of success and failure, that is always equal to unity. So I will calculate standard error by substituting the values in this formula. Then I will calculate Z. Since Z comes out to be 2.03 and it is case of two-tailed test, so critical values I will take at 5% plus minus 1.96. Since calculated value lies beyond these limits, null hypothesis may be rejected. And what will be conclusion? Die is not fair. If P is equal to 0.5, it means number of head and number of tail, they are same, die is fair. But if P is not equal to 5, that means outcome of head and tail, it is case of dice. Dice means outcome of number 1, 2, 3, 4, 5, 6. That is not same, right? And it is, since it is a 6-face die, or you can take here the statement of, let it be coin. Here number, I have taken odd number. For odd number it is correct. For odd number it is correct. For odd number, since there are three odd numbers, 1, 3, 5, so P will be 0.5. Out of total 6 numbers, 1, 2, 3, 4, 5, 6, odd number are 1, 3, 5, that is 3 out of 6, P will be 0.5. It is very much correct, right? Then next is difference between two population proportions. It is P1 minus P2 over standard error of P1 minus P2. Now here there are two districts and I have taken two samples. One is of 1,000 persons and another one is of 800 persons. And 450 persons, they are regular consumer of tea in district A and 400 in district B. I will calculate P1 and P2 and I have to test whether the difference between two districts. So far as drinking habit is concerned, it is significant or not. Then I will formulate null hypothesis as P1 is equal to P2. That means difference regarding the drinking habits in two districts is insignificant. And alternate shows that difference between two districts so far as drinking habits are concerned, it is significant, right? So I will calculate small p1 and small p2. Small p1, that means sample probability of consumers taking tea in district A, it will be 450 over 1000, and in district B, it will be 400 over 800. Now, I will calculate P through the pooling method. This is pooling method. N1 into P1 plus N2 into P2 over N1 plus N2. I will substitute the values. P comes out to be this. Q will be 1 minus P. And I will calculate standard error. This will be the formula of standard error. I will substitute the values. Standard error comes out to be this. And then I will substitute the values in Z. It comes out to be 2.1097. Since calculated value of Z lies beyond the critical values, then null hypothesis may be rejected. If I reject the null hypothesis, that means P1 is not equal to P2. That means there is significant difference between the two districts so far as drinking habits are concerned. Right? Hanji. I hope this much is clear. Any doubt till now? Any doubt or any point you want to represent or you want to discuss? Any point? Should I move further? Any point till now? Should I move further? The next is case of t-test. It is small sample test, and here you have to test the difference between sample mean and population mean, then difference between two population means. It is further divided into two categories. One is in case of independent sample and another is the case of dependent samples or paired sample. First of all, one sample t-test, t-distribution, it is given by Professor Gossett, right? Professor Gossett has given this distribution, and t-test that follows the t-distribution. These are some of the examples. Does the average volume of liquid filled in soft drink bottles match the 12 ounces advertised on the label? That means you have to test whether the average volume of levels of soft drink bottles, that is 12 ounces. That means mu is equal to 12, right? Mu is not equal to 12. That will be your alternate hypothesis. Now here, on the basis of 20 students and less than 30, that means it is case of t-test. Can we conclude that average score this year is more than 400? Again, here average score you have to test for the population on the basis of sample. It is again case of t-test since n is less than 30. One thing here I want to add, when we calculate manually, when we differentiate it between t-test and z-test, but when we calculate through software, then we always apply t-test because softwares have inbuilt programming that they can calculate or adjust values accordingly for the sample size, right? Then test of hypothesis about the population mean. It is t is equal to mean minus mu over s over under root n. And here these are the values of x. First of all, I will calculate mean and variance, that is unbiased estimate of variance through this formula, and mean sigma x over n. And since claim is that mean weight of population is 48 kg, so it will be mu is equal to 48 or mu is not equal to 48, right? Here s will be equal to sigma x minus x bar square, where I have written x1, this means x bar, right? Mean. X1 represents here mean, right? Then I will calculate standard deviation to this formula. I will put this standard error in this formula of t, and t comes out to be 0.525, which is in between the limits of 2.776. So null hypothesis may be accepted. That means average weight is equal to 48 kg. This is case of one sample t-test. Now there are two types of samples. First is independent sample t-test, and another one is paired sample t-test. Now, what is difference between both independent sample t-test and paired sample t-test? When two samples, as a name depict, that they're entirely independent, they're not related to each other, then it is case of independent sample t-test. But when two samples they are related to each other, then that is case of paired sample t-test. Let it be there are two brands of fertilizers, and I applied it on two different plots, and these are the data of field, right? These are the data I have taken for fertilizer 1 and fertilizer 2. Since these are two independent fertilizers, there is no relation between these two. So it is case of independent sample t-test. And here there are two groups. They are not related to each other. It is case of independent sample t-test. This is formula of t-test, t-statistic, mean 1 minus mean 2 over standard error, and standard error is S into n1 plus n2 divided by n1, n2 under the rule. Now I have to examine whether the difference between mean marks secured by student above two groups, that is significant or not. Then null hypothesis will be mu1 is equal to mu2, and alternate will be mu1 is equal to mu2. That means null hypothesis depicts that there is insignificant difference between mean marks secured by students of two groups, and alternate depicts that there is significant difference between mean marks secured by students of above two groups. Now I will calculate mean 1 and mean 2. I am assuming that you know how to calculate mean 1 and mean 2 and how to calculate standard deviation. Then I will calculate standard S, that is unbiased estimate of two, two populations or two sample variances. This will be sigma x1 minus x1 bar square plus sigma x2 minus x2 bar square over n1 plus n2 minus 2. I will substitute the values and S comes out to be 10.42. I will substitute the values in T, and T statistics come out to be 0.571. And since it lies in the acceptance region, right? It is 2.145 and it lies in between these critical value. So null hypothesis may be accepted. That means there is insignificant difference between the marks of students of two groups, right? Now next is the paired sample t-test. Again, you have to compare the two population means, but here two population means they are related to each other, right? They are paired with each other. Like if I take the sales before advertisement and sales after advertisement of few salespersons, then this will be pair test, right? If I take the pair before and after measurements on a single group of subjects or patients, again this is pair t-test. Two measurements on the same subject or entity, right and left eye, again these are the paired. Does the diet work? I have given diet to few persons. Then I have checked whether with that diet weight increases. That is pair t test, because there is group of 10 students, let it be, and I have given them some specific diet. Then whether with that specific diet the weight has increased or not, if I have to test this, then this is pair t test. Now, is new teaching method better than the standard methods? Again, I have given the new teaching method to few students. I taught them with new method. Then I checked the difference between marks, whether there is significant difference between marks or not. Then that means I have taken the marks of that very students before new method, new teaching method, and after new teaching method. This is again case of pair t-test. Then whether the new type of eye drop that work better than standard drops, if it works better than standard drops or not, that means I have given the eye drops, I have given the standard drops to person, then I have given the new type of eye drop to a person, then I compared the two, then again it is both are applied to same person, so it is case of pair t-test. It is the formula of pair t-test, d bar over s over under root n. It is standard error. Standard error is calculated as s over under root n. Here, 10 students of a class, they are given a test in statistics. Results are given as below. You are given degree of freedom as 9 and t at 5% level of significance 2.26. Remember that for t critical values, they are calculated from table through degrees of freedom, and degrees of freedom that are in case of one sample, degree of freedom is n minus 1, right? In case of independent samples, degrees of freedom are n1 plus n2 minus 2. That is 9 plus 7, 16 minus 2, 14 in this case, right? And for paired sample test, t-test, degrees of freedom are again n minus 1. There are 10 students, degree of freedom will be 10 minus 1, 9. First of all, I will calculate mean, then standard deviation of difference. These are the marks. I will take difference, then I will calculate mean of this, then I will calculate standard deviation of this. After calculating mean and standard deviation, I will put in this formula, and since here t comes out to be 1.437, it lies in the acceptance region as critical value is 2.262. So it is less than that, it lies in acceptance region, so null hypothesis may be accepted. That means new method of coaching that has not benefited the students. Any doubt? This is all about t-test, z-test and hypothesis testing. Any doubt till now? Any doubt? Now the session is open to you for any interaction or any discussion.
Yes.
This
Thank
is
you,
all
ma'am.
about I have explained. Now the session is open to you for discussion further.
So, few students have a questions they want to discuss with you.
Yes.
Hi, ma'am, I just had one question. So,
Yes.
in the parity test, like there are two variables. So, they are interdependent or they are like independent variables? Are they
In case
related
of
or
in case of paired sample test,
yeah?
variables are always interdependent. They are linked with each other. They are not independent. They are
Okay.
linked to each other, right?
Okay, ma'am.
As
Thank.
I have explained you that let it be, I have given a test to few students and I have taken scores before test and after test. That means these scores are of same students. They are linked to each other, right? So
Okay.
it is case of pair test.
Okay, ma'am. Thank you.
Yes.
Okay, ma'am. Thank you.
Anyone else?
Yes, one more.
Yes.
Like there are ma'am two tails. One is right tail and the other one
Yes.
is left tail. So basically, what's the difference between them?
In case of right tail, we try to check the testing of null hypothesis. We try to reject null hypothesis or accept. In case of right tail, rejection region is on the right side, right? And in case of left tail, rejection region is on the left side. As already I have already explained. Let me open the PPT. Like this. This is case of right tail. Here rejection region is only on the right side, right? I have taken all other areas acceptance region. That means any calculated value, if it is negative, it is automatically accepted in case of right tail. But if it is case of left tail, rejection region is only on the left side. And any positive value, that will always be accepted, right?
Ma'am, if it comes in the negative.
If it comes negative and it is less than the critical value, then it is rejected. Otherwise, it is accepted.
Okay, ma'am.
Let it be values minus 2.06, then it will be rejected in this case. But if the value is, let it be minus 1.23, then it will be accepted. Since minus 1.23 is more than minus 1.65, you know, in negative, as the value is smaller, it is on the upper side, right? Clear?
Thank you, ma'am.
Okay.
Okay, it's one more.
Anyone else?
Yes.
Anyone else?
Good afternoon, ma'am. Ma'am, I have a
Yes, good
question. Like
afternoon.
you explained, like there are two types of error, and
Yes.
type one error is more dangerous because in that, like the pers- person is innocent person is convicted. But if the type two error is declined, is there any possible way we can accept that?
uh, I couldn't get you. That is there any possible way to control the type 2 error? Are you
Yes,
asking
yes,
this?
yes,
Okay.
ma'am.
Yes. Actually, we measure the power of test. Once we decide the value of type 1 error, that is level of significance, after that, we try to maximize the power of test. And what is power of test? It is 1 minus probability of type 2 error, right?
Okay.
After deciding the level of significance, suppose I decided the level of significance as 5%. After that, we try to maximize power of test. We opt that very option where power of test is maximum. And what is power of test? It is 1 minus type 2 error, right?
Yes, ma'am. Okay, ma'am. Thank you.
Okay, okay. Anyone else? Anyone else? Any
Okay,
doubts?
thank you so much, ma'am. There's no doubt, and thank you for the session. Now, students want click a group photo with you. So,
Okay.
okay, just 1 second, just 1 second.
I hope you have learned a little bit from my session. Some, I think, maybe something is added to your knowledge.
Okay, thank you so much, ma'am, and the nurse as well. Just 1 second, they are settled down. Just 1 second. Yes, now they are settled down. Thank you so much, ma'am, and Ernest.
Thank you, Anu. Thank you, Dr. Shalu.
Yeah, thank you. Your mic, and you need, ma'am, you need to unmute your mic. Yeah.
It is my pleasure to interact with you. Hope that all the students have really enjoyed and they have learned something from my lecture. And if there are still any doubts, you can always contact me on my email ID, shalubatrahmv@gmail.com. You can send query. I will definitely reply to your queries.
Thank you so much, ma'am.
Okay. Thank you.
Thank you so much. Anu, thank you very much as well.
Okay.
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 Should I leave now?
Yeah, you can.
Okay.
Thank you so much.
Thank you very much.
Bye.